Hello everybody. Today we are going to discuss some sampling procedures by attributes. In this session we are going to discuss some basic sampling procedures by attributes. The entire topic is subdivided into the following subdivisions. 1. Definition of single sampling plan by attributes and derivation of its OC curve. 2. Effect of changes in the OC curve of the single sampling plan. 3. ATI and AOQ of single sampling plan. 4. Construction of single sampling plan. 5. Definition of double sampling plan and derivation of its OC curve. 6. ASN, ATI and AOQ of double sampling plan. 7. Comparison of single sampling plan and double sampling plan. 8. Conclusion. Definition of single sampling plan by attributes, in short SSP, and derivation of its OC curve. Let the units are submitted for inspection in lots of size capital N each. The sample of small n units is taken at random from each lot and is inspected. The number of non-conforming units, that is defectives, in each sample, say D, is identified. If the sample contains more than C, a stated number of allowable non-conforming units, that is defectives, that means D is greater than C, the whole lot is rejected. If the number of defectives D less than or equal to C, the whole lot is accepted. The number C is called the acceptance number, that is the maximum tolerable number of defectives in a sample of size n. When the number of defectives is more than C, resulting in the rejection of the whole lot, then the remainder of the lot is inspected 100% and the defectives found are replaced with the non-defectives. This procedure is called rejection rectification procedure. So, in single sampling plan, capital N the lot size, small n the sample size, C the acceptance number are the parameters of the plan and generally denoted by NNC. If D is the number of defectives found in a sample of size small n, then the estimate of the lot quality is given by P dash is equal to D by N. Then the number of defectives X out of n items follow hypergeometric distribution with the probability function given by P of x is equal to D C x n minus D C n minus x divided by n C n, where D being the total number of defectives present in the lot of size capital N. If n is assumed to be very large and small n is assumed to be small, which is the usual practice in industrial manufacturing situations, the probability can be approximated by binomial model with the probability of getting x defectives is given by the probability function P of x is equal to n C x p to the power x 1 minus p to the power n minus x. In addition to the above condition, if the lot size is sufficiently large and if NP is less than 5, then the probability can be approximated by the Poisson model with the probability function P of x is equal to e power minus NP, NP to the power x by x factorial. Then the probability of acceptance of the lot based on the single sampling plan is given by P of A is equal to probability of x less than or equal to C, that is equal to summation 0 to C e power minus NP, NP to the power x by x factorial, because up to number of defectives C we are going to accept the lot. The image of OC curve of such a sampling plan is given below. The x axis denotes the percentage defective per lot and y axis denotes probability of acceptance. We have almost an S shaped curve. So, this is the OC curve of the single sampling plan drawn for n is equal to 52 and C is equal to 3. Let us study the effect of changes of n and c separately of the OC curve of the single sampling plan. Effect of sample size. The effect of keeping the acceptance number as constant and increasing the sample size. Increasing the sample size while holding C constant increases the producer's risk and reduces the consumer's risk. The situation is explained in the following graph. Observe that when we kept C constant, n goes on increasing, the OC curve sharply decreases. That means, the chance for probability of acceptance goes on reducing. So, the risk for the producer is more. Effect of change in the acceptance number. The effect of keeping the sample size as constant and increasing acceptance number. Increasing acceptance number C while holding n constant decreases the producer's risk and increases the consumer's risk, which is explained in the following graph. Here you observe that when we keep n constant and C goes on increasing, the OC curve bulges. That means, it gives more chance for accepting the lot with the poor quality, hence increases the consumer's risk. ATI and AOQ of single sampling plan. What is ATI? Average total inspection. The number of items inspected per lot is a random variable which is described as follows for single sampling plan. A sample of size n is always inspected. That is, for each expected lots only n items are inspected, whereas in the rejected lots all the capital N items are inspected. That is, the sample size n plus the remainder of the lot n minus n. If Pa is the probability of acceptance of the lot, we have the distribution of inspection is given by Pi is equal to small n for accepted lot, capital N for rejected lot. Then average total inspection denoted by I is given by n into Pa plus capital N into 1 minus Pa. When you simplify that, you will get the formula small n plus capital N minus small n into 1 minus P. Average outgoing quality of the single sampling plan. The quality of the lot after inspection is referred to as the outgoing quality. For single sampling plan, the average total number of items inspected per lot is I. Therefore, n minus I items are not inspected. If P is the quality of the lot, then the average number of defectives passed out of the inspection is n minus I into P. Hence, average outgoing quality is given by average number of defectives passed out of the inspection per lot of size n, that is given by n minus I into P divided by n. Replace I by its value, then the formula is capital N minus small n minus capital N minus small n into 1 minus P into P divided by capital N, that is n minus n small p into Pa divided by capital N, that can be written as 1 minus small n divided by capital N into P into Pa, which is approximated to P into Pa for the lot size sufficiently large. AOQL. The maximum value of AOQ is the AOQ limit, are denoted as AOQL, denoted by the letter PL. The main concept in single sampling plan is obtain the parameters n and c. Several procedures are available to find out the values for n and c. One such procedure is AQL, LQL plans. So, construction of single sampling plan, that means obtaining the estimates for n and c. Here given P1 and P2, alpha and beta, we construct a single sampling plan such that its OC curve passes through the 2 points P1 1 minus alpha and P2 beta. The parameters n and c are obtained such that it satisfies the following conditions. The conditions for the producers and conditions for the consumers risks are attained. That is, P of accepting a lot of quality P1, that is equal to summation x is equal to 0 to c e power minus n P1 to the power x divided by x factorial, that is equal to 1 minus alpha. Probability of accepting a lot of quality P2, that is equal to summation x is equal to 0 to c e power minus n P to the power x by x factorial. Both producers and consumers values are attained. The above two equations can be solved by trial and error method. Take an arbitrary value of c from equation 2 and using cumulative Poisson table obtain the value of NP2, say m. Since we know the value of P2 from the table, we can obtain the value of n. Thus, we have a trial plan given by n and c. Using these values of n and c, in equation 1 obtain the value of alpha. If the calculated value of alpha is different from the given alpha, change the value of c and repeat the procedure until a closer value of alpha is obtained of that of given alpha. So, that pair n and c is the selected parameters of the single sampling plan. Double sampling plan and derivation of OC curve. In single sampling plan, we have observed that since we are taking only one sample, a good lot may be rejected or a bad lot may be accepted. That means, it does not lead to the acceptance or rejection of the lot. One has to restore to some other sampling plans to take a decision to accept or reject the lot. In other words, a single sample is not bad enough to reject a lot straight away or good enough to accept the lot. In this situation, a second sample is necessary and a decision is taken on the basis of the results of the first and the second samples combined. One method of selecting a second sample to arrive at a more reliable decision is known as double sampling plan. In this scheme, a second sample is drawn from the same lot and the decision is taken according to the procedure given below. The parameters of the double sampling plan are small n1, small n2, c1 and c2, generally denoted by capital N the lot size, n1 the sample size of the first sample, n2 the sample size of the second sample, c1 acceptance criteria based on the first sample, C2 acceptance criteria based on the combined sample. Operating procedure. Step 1. First inspect a sample of size small n1 from a lot of the size capital N. Step 2. If the number of defectives found in the sample, say D1 is less than or equal to C1, accept the lot. Step 3. If the number of defectives D1 exceeds C2, reject the lot and inspect the remainder of the lot 100% inspection. Step 4. If the number of defectives found is between C1 and C2, that is, if C1 less than D1 less than or equal to C2, inspect the second sample of size N2. Step 5. If the number of defectives observed in the second sample D2 plus the first sample combined D1 plus D2 is less than or equal to C2, accept the lot, otherwise reject the lot. Step 6. Correct or replace defectives observed by good ones. OC function. Let P x n p equal to e power minus np to the power x divided by x factorial is the probability of getting x defectives in a sample of size n from the lot of quality p under Poisson distribution. If the number of defectives found in the first sample of size n1 is less than or equal to C1, we accept the lot, and probability of accepting the lot based on this sample is denoted by P1 given by summation x is equal to 0 to C1 e power minus n1p to the power x by x factorial. In short, that is written as summation x is equal to 0 to C1 p x n1p. A second sample is taken when D1 is between C1 and C2, that is C1 less than D1 less than or equal to C2. If the number of defectives found D2 in the second sample of size n2 is such that D1 plus D2 is less than or equal to C2, we accept the lot. This happens in the following mutually exclusive ways. First case, the first sample has a number of defectives C1 plus 1. Then in the second sample, if the number of defectives is C2 minus C1 minus 1, then the number of defectives in the combined sample is less than or equal to C2, hence we accept the lot. So, in this case the probability of acceptance is given by summation x is equal to 0 to C2 minus C1 minus 1 p x n1 p. Suppose in the first sample the number of defectives is C1 plus C2, the number of defectives allowable for second sample is C2 minus C1 minus 2. So, that the number of defectives in the combined sample will be less than or equal to C2. In this case, the probability of acceptance is given by summation x is equal to 0 to C2 minus C1 minus 2 p x n1 p. So on we continue. Suppose in the last step, suppose the first sample has C2 defectives, then the second sample should have 0 number of defectives. Therefore, the number of defectives in the combined sample will be C2. Again the sample is lot is accepted. In this case, the probability of acceptance is given by P naught n2p. When we sum all these probabilities, the probability function is given by summation y is equal to C1 plus 1 to C2 p of y n1p summation x is equal to 0 to C2 minus y p of x n2p. Hence, probability of acceptance of the lot based on the second sample given by P2 is equal to summation y is equal to C1 plus 1 to C2 p of y n1p summation x is equal to 0 to C2 minus y p of x n2p. And the probability of accepting the lot based on the double sampling plan is given by P a is equal to P1 plus P2, that is given by summation x is equal to 0 to C1 p of x n1p plus summation y is equal to C1 plus 1 to C2 p of y n1p summation x is equal to 0 to C2 minus y p of x n2p. How to derive ASN, ATI and AOQ of double sampling plan. Average sample number ASN of double sampling plan. In the double sampling plan, the first sample is always inspected on sampling basis. Thus, N1 items are always inspected and N2 items are taken if the number of defectives in the first sample exceeds C1 but less than or equal to C2. Therefore, in the long run, the number of units inspected on sampling basis is a random variable. The expected value of the number of units inspected on sampling basis is given by ASN is equal to N1 plus N2 summation x is equal to C1 plus 1 to C2 P of x N1P. Average total inspection ATI. Only N1 items are inspected per lot if the lot is accepted based on the first sample, and this happens with the probability P1. Only N1 plus N2 items are inspected if the lot is accepted based on first and second sample combined, and this occurs with the probability P2. All the N items are inspected if the lot is rejected. This happens with the probability 1 minus PA. Hence, average total inspection ATI is given by I is equal to N1 P1 plus N1 plus N2 into P2 plus capital N into 1 minus PA. Average outgoing quality AOQ. The average outgoing quality for double sampling plan is given by AOQ is equal to N minus I into P divided by capital N. Replace the value of I, then it is given by N minus N1 into P1 plus N minus N1 minus N2 into P2 into P divided by N. Let us compare the single sampling plan and double sampling plan. Single sampling plan is simple, easy to design and administer. Compared to single sampling plan, double sampling plan is not simple, not easy as compared with the single sampling plan. Single sampling plan calls for decision on acceptance or rejection based on the evidence of only one single sample from the lot. Double sampling plan appears more convincing to say that the lot is accepted or rejected after inspecting two samples. Single sampling plan generally involves more number of inspection than double sampling plan. Double sampling plan involves less number of inspection than single sampling plan, hence cost and time is reduced. Discriminatory power between good and bad lots by single sampling procedure is lower than that of double sampling plan. Discriminatory power between good and bad lots by double sampling plan procedure is higher than that of the single sampling plan. Conclusion. In this lecture, we studied the single sampling plan for attributes, its OC function and its properties. We learned the change in the shape of the OC curve when the sample size changes, fixing the acceptance number, and also the changes in the OC curve when acceptance number changes, fixing the sample size. We discussed the construction of parameters of the single sampling plan given 2 points on the OC curve, the double sampling plan and derivation of its OC curve, the comparison between single and double sampling plan. Thank you.